The block that just over a mile long, over 800 tons, placed 20 feet in the air without mortar, and that's not even the heaviest stone they cut. The official version says ancient builders worked with ropes, ramps, and raw manpower. That's the answer they teach in schools. And for most of the ancient world, that answer works just fine. But then, you run into 7 specific structures, 7 places on this planet, where the ramps and ropes answer doesn't just struggle, it falls apart completely. Not because the stones are big. Big stones, humans can move. The problem is the combination. The weight, and the precision, and the altitude, and the fact that in several of these places, the largest blocks were never even finished, as if whoever was doing this stopped mid-sentence, walked away, and left behind a question nobody has answered since. That's what this is about. Not ancient aliens, not mythology. Engineering, the kind of engineering that modern structural professionals, people who build skyscrapers and bridges for a living, look at and go quiet. Let's start in Lebanon, because the first site alone changes the frame for everything that follows. Baalbek, ancient Heliopolis. A Roman temple complex sitting on a hillside in the Bekaa Valley, about an hour east of Beirut. The Romans built magnificent things, aqueducts, colosseums, roads that lasted 2,000 years. Nobody disputes their engineering genius. But when Roman engineers arrived at Baalbek, they built their temple on top of a foundation that was already there, a foundation made of stones that, by any modern standard, should not have been possible for anyone to place. The trilithon, 3 limestone blocks set into the western retaining wall of the Temple of Jupiter. Each one is roughly 19 meters long, that's about 62 feet. Each one is approximately 4.2 meters high and 3.6 meters thick. And each one weighs somewhere between 750 and 800 tons. Just to give that number some shape, one of those blocks weighs roughly as much as 150 fully loaded school buses. 3 of them sit side by side, raised about 6 meters, nearly 20 feet off the ground. And the joints between them? A piece of paper will not fit between those stones. No mortar, just stone against stone, fitted so precisely that the contact is essentially continuous. Now, here is where the official version starts to crack. Engineers estimate that moving a single one of those blocks, just moving it horizontally on flat ground, would have required a coordinated force of somewhere between 15,000 and 20,000 workers. Then those workers would have needed to raise each block 20 feet into the air and position it with sub-millimeter precision against its neighbor. The Romans were good. They were very, very good. But no Roman text, no inscription, no engineering manual from antiquity describes how this was done. The method is not recorded, it is simply there. And the trilithon is not even the heaviest stone at Baalbek. Still sitting in the quarry, about 900 meters from the temple complex, is a block that was never moved. Archaeologists call it the Stone of the Pregnant Woman. It weighs an estimated 1,000 tons. 900 meters away lies another, rediscovered in the 1990s, now called the Stone of the South, estimated at around 1,242 tons, and then discovered in 2014 by archaeologists from the German Archaeological Institute, a third. The Forgotten Stone, roughly 19.6 meters long, 6 meters wide, at least 5.5 meters high. Its weight is estimated at approximately 1,500 tons. That is, by current assessments, the largest single stone ever quarried in recorded human history. It never left the ground. And nobody knows whether that is because it was too heavy to move, or because whoever was cutting it simply stopped. Coincidence? Possibly. But you don't abandon 3 massive quarry stones of increasing size unless the project ran into a wall. The question is, what kind of wall stops people who were already moving 800-ton blocks through the air? That question gets more uncomfortable when you move to the other side of the world, high in the Andes of Peru, at an elevation of about 3,700 meters above sea level, that's more than 12,000 feet, where the air is thin and temperatures drop hard at night, sits a complex called Sacsay-Huaman. overlooking the ancient Inca capital of Cusco. The Incas built it, and the archaeology is not in dispute on that point. What is in dispute is the how, because the Incas, for all their organizational brilliance, had no iron tools, no wheels, and no draft animals strong enough to move what they moved. The terrace walls at Sacsayhuaman are made of polygonal limestone blocks. The largest blocks at the site are estimated to weigh somewhere between 128 and 200 tons, the upper end of that range, representing some of the heaviest stones used in any building in pre-Columbian America. The stones are not cut in regular shapes. They are irregular polygons, 5 sides, 7 sides, asymmetric angles, and they interlock with each other the way puzzle pieces lock. The joints between them are so close that a single piece of paper will not fit between many of the stones. After more than 500 years of earthquakes, including earthquakes that leveled colonial Spanish buildings built directly on the same hillside, the Inca walls still stand. Structural engineers who have studied this note that the rounded corners, the interlocking geometry, and the slight inward lean of the walls work together as a seismic dampening system of extraordinary sophistication. That is not primitive construction. That is applied materials science. But here is the number that stops engineers cold. The primary quarry for the stone used in Sacsayhuaman is located several miles from the construction site, uphill and across broken Andean terrain. These blocks, some weighing more than 100 tons, were moved without wheels, without iron, without pulleys made of anything stronger than fiber. Experimental archaeology has attempted to replicate the process. In documented trials, a team using ropes and log rollers managed to move a much smaller megalith with around 100 people at a reasonable pace on flat ground. The largest stones at Sacsayhuaman weigh at minimum twice what those experiments used, on terrain that is not flat. At altitude where the human body produces roughly 30% less work capacity than at sea level, the official answer is, they figured it out. And that may well be true. But the engineering gap between "they figured it out" and any surviving description of how that gap is total, there is no record, no drawing, no toolset that demonstrably explains the precision of those joints on 200-ton irregular polygons. And here is where it gets genuinely uncomfortable, because Bolivia, less than 300 miles to the southeast of Sacsayhuaman, has a site that sits at an even higher altitude, 3,850 meters above sea level, on the Altiplano, near the ruins of Tiwanaku, called Puma Punku. The Tiwanaku civilization built here, and radiocarbon dating places the main construction phases consistent with their known cultural expansion. That much is not disputed. What is disputed is everything else about this place. The signature feature of Puma Punku is its H-shaped blocks. They are made primarily of andesite, a volcanic stone that sits at around 6 or 7 on the Mohs hardness scale. For reference, a copper or bronze chisel, the hardest metal tool the Tiwanaku are documented to have possessed, sits at about 3 on the same scale. You cannot cut Mohs 6 with Mohs 3. That is not an opinion. That is materials science. Yet each H-block has been documented to contain approximately 80 distinct faces, cut with right angles so precise that even today a razor blade cannot pass between fitted surfaces. Petrographic studies confirm the blocks are andesite, sourced from quarries across Lake Titicaca, roughly 90 kilometers away, transported across water and then up onto the Altiplano. In 2019, French materials scientist Joseph Davidovits, who coined the term geopolymer and is the leading figure in the field of ancient synthetic stone, published a paper in the peer-reviewed journal Ceramics International arguing that some Puma Punku megaliths were not carved from solid rock but cast in molds from a mineral mix. The evidence he cited includes organic carbon in the stone matrix and an amorphous binder phase, visible under scanning electron microscopy, that he argues is inconsistent with naturally formed andesite. His critics argue back that the organic carbon has alternative explanations and that replication of the proposed process has not been achieved. So the debate is live. Neither side has closed it. What that means is this: either the Tiwanaku cut Mohs 6 andesite to razor tolerances, with bronze tools, which materials science says shouldn't work. Or they were casting synthetic stone in the high Andes 1,000 years before we developed the chemistry to understand what they might have been doing. Both options require a serious conversation that the official curriculum hasn't started having. Now lay the data points side by side so far. Baalbek, 800, ton blocks, 20 feet in the air, knife blade joints, no surviving account of the method. Sacsayhuaman, 200, ton irregular polygons, multi-mile transport without wheels, precision that has outlasted 5 centuries of Andean earthquakes, no surviving technical record. Puma Punku, andesite harder than the tools supposed to have cut it, H-blocks with 80 faces and razor tolerances, a peer-reviewed geopolymer hypothesis that the scientific community has not dismissed but also not explained away. 3 sites, 3 separate continents of explanation required, and we haven't reached the structure that has consumed more scientific attention than all of them combined. Giza, Egypt, the Great Pyramid of Khufu. Built around 2600 BCE, give or take a few decades, by a civilization we know a great deal about enough to know it was sophisticated, organized, and capable of extraordinary things. The pyramid originally stood about 146 meters high. Each side of the base measures approximately 230 meters. It is composed of an estimated 2.3 million stone blocks. Most of those blocks weigh between 2.5 and 15 tons each. The granite ceiling beams above the king's chamber, hauled from quarries at Aswan, more than 800 kilometers to the south, weigh between 25 and 80 tons each. The total mass of the structure is in the range of 6 million tons. Here is the number that Live Science ran the calculation on. If the pyramid was built in roughly 20 years, as the historical record suggests, then a block had to have been set into place approximately every 5 minutes, around the clock, every day, for 2 decades. Not moved. Moved, positioned, and fitted every 5 minutes. That is the logistics problem. That is the number the ramps and ropes model has to satisfy. And in 2013, archaeologists got closer to an answer than they'd ever been, but the answer opened new questions. At Wadi al-Jarf, on the Red Sea coast, archaeologist Pierre Tallet discovered the oldest papyrus rolls ever found. They were written by a man named Mira, a mid-level work supervisor, and they documented the daily transport of limestone blocks from the quarry at Tura across the Nile to Giza during the 27th year of Khufu's reign. It is a logistical diary, a real one, written by a real person at the time of construction. It is extraordinary evidence of a massive, coordinated, highly organized operation, and what it confirms is the scale of the undertaking. What it does not contain is the engineering specification for how 80-ton granite ceiling beams were raised 43 meters into the air and placed within the pyramid's interior chambers. That part still not in the record. The pyramid's base is level to within 2.1 centimeters across its entire 230-meter span. 2.1 centimeters. Modern laser survey equipment placed on the site has confirmed this. The 4 corners are oriented to the cardinal directions to within a fraction of a degree. In 4,600 years, no single building has matched that combination of scale and positional accuracy until the modern era of precision surveying. The official version says, determined people with copper tools, wooden sledges, and enough organizational willpower can achieve this. They are not wrong that people built it. The graffiti is there, the papyrus is there, the workers' village is there. What is not there is a satisfying engineering answer to how any pre-industrial workforce achieves millimeter-scale leveling across a 230-meter base or raises multi-ton granite beams through a structure that is simultaneously being built around them. We're not at the core yet, because there is a site that most people in this conversation overlook, a site that forces a different kind of question. Not just how was this built, but how was this known? Newgrange, Ireland. A passage tomb built around 3200 BCE, older than Stonehenge, older than the Great Pyramid, by roughly 500 years. It is a large mound, about 85 meters in diameter, faced with white quartz on the exterior. The passage inside is 19 meters long, aligned with mathematical precision toward a single astronomical event, the winter solstice sunrise. On the morning of the winter solstice, and only on that morning, sunlight enters through a small opening above the entrance called the roof box and travels the full 19-meter length of the passage, illuminating the chamber at the end for approximately 17 minutes. The alignment is accurate to within a few minutes of arc. It was engineered into the structure around 5,200 years ago. Archaeoastronomers have confirmed this. It is not an accident of geometry. To build this alignment, the architects of Newgrange needed to know the precise azimuth of the winter solstice sunrise at that latitude, account for the passage's slope and length, and cut the roof box to the correct angle, all before a single stone was placed. That is not folk knowledge. That is applied astronomy, encoded in megalithic architecture, 500 years before the earliest Egyptian pyramid. And the stones themselves are not local. The white quartz facing of the mound was transported from the Wicklow Mountains, roughly 80 kilometers to the south. The large curbstones and interior orthostats, some weighing several tons, were sourced from different geological regions and moved to the site without metal tools, without the wheel, and without any surviving technical record of the process. The world was supposed to be in the Stone Age in 3200 BCE. The Newgrange builders were encoding precise astronomical constants into permanent stone architecture. Those two things do not fit in the same sentence, but they are both true. Now step east. Turkey. The site called Göbekli Tepe, sitting on a limestone ridge in southeastern Anatolia, first excavated seriously in the 1990s under the direction of archaeologist Klaus Schmidt of the German Archaeological Institute. The radiocarbon dates from the site place its construction layers at approximately 10,000 to 9,600 BCE. That is not a typo. 12,000 years ago, before agriculture, before pottery, before the earliest evidence of settled village life in the archaeological record. The textbook says that the cognitive and organizational capacity required to build a monumental temple complex, to plan it, quarry stone for it, transport it, and carve figurative reliefs into it, was a product of civilization. Settled life first, temples later. Göbekli Tepe inverts that sequence entirely. The T-shaped pillars at the site, some of them weighing up to 10 tons, carved with reliefs of foxes, snakes, and other animals, were placed there by people who, by the conventional model, were hunter-gatherers. No granaries, no permanent settlement at the site itself. Archaeologists have identified more than 200 of these pillars across the excavated and unexcavated portions of the site. The current estimates suggest only a small fraction of the full site has been excavated. Schmidt himself, before his death in 2014, proposed a theory that inverted the standard archaeological timeline. Perhaps it was not agriculture that enabled the construction of temples, but rather the organizational demands of building the temples that drove the development of agriculture. The site forced people to settle, to grow food, to build social hierarchies capable of coordinating large labor projects. The monument came first. Civilization followed. That is not a fringe hypothesis. That is what the lead archaeologist of the primary institution excavating the site put forward, and it has not been answered. How did pre-agricultural people quarry 10-ton limestone pillars, transport them up a ridge with no wheeled vehicles, and carve zoomorphic reliefs precise enough to still be identifiable 12,000 years later? The official version does not have a satisfying answer. It has a shrug, dressed up in academic language, which brings us to the last site on this list. And this one is different, because the engineering problem here is not weight or precision or astronomy. It is chemistry. Easter Island, the Moai. Massive stone heads, actually full torso figures, most of the body buried, carved from compressed volcanic ash called tuff. The largest standing Moai is about 10 meters tall and weighs around 75 tons. The largest Moai ever carved, called El Gigante, still lies at the quarry at Rano Raraku unfinished, attached to the bedrock. estimated at around 270 tons. But the engineering problem that genuinely stops modern materials experts is not the carving. It is not even the transport. Though moving 7 5-ton figures across an island with no trees large enough for rollers, a deforestation that had already occurred by the time the largest moai were being moved, presents its own serious questions. The problem is the redstone hats, called pukao. They are separate cylinders of red scoria, a different stone type from the moai themselves, sourced from a separate quarry on the other side of the island. Some of them weigh 12 tons. They were placed on top of the moai heads, often at heights of 10 meters or more. Researchers from UCLA published a study examining the pukao transport and placement problem. Their analysis found that the most mechanically coherent explanation for how the pukao were raised to the tops of the standing moai without scaffolding materials capable of holding that load involved a par-buckling technique using ropes and a ramp of fill material. Possible, difficult, and dependent on rope technology and coordination that the island's population, by that point, severely depleted by the environmental collapse of deforestation, would have been struggling to sustain. The Easter Island story is often told as a cautionary tale about civilization collapsing under its own weight. What it rarely gets told as is a story about engineering, a people who, at the height of their culture, figured out how to quarry, carve, transport, and precisely erect multi-ton stone figures, and then keep doing it while their resource base disappeared beneath them. That is either the most tragic engineering story ever told, or it is evidence of a technical capacity we still don't fully understand. Lay all 7 data points side by side now. Baalbek, the largest stones ever raised into a wall in recorded history, with joints a blade can't pass through, and a quarry full of even larger stones that were abandoned mid-process. Saksai Huaman, polygonal walls in the Andes built without wheels or iron that have outlasted every colonial structure built on the same ground. Pumapunku, stone harder than the tools supposed to have shaped it, cut to tolerances that should require machine precision, and a peer-reviewed hypothesis that it may have been cast rather than carved. The Great Pyramid, a 6 million ton structure leveled to within 2 centimeters across a 230-meter base, with its granite internals sourced from 800 kilometers away and raised into position at a rate the official timeline demands, but the engineering world cannot fully replicate. Newgrange, an astronomical observatory sealed in stone, 5,200 years ago, aligned to the solstice to within minutes of arc, by people with no metal and no written record. Göbekli Tepe, a monumental temple complex, built 12,000 years ago by people the textbooks say were too early in human history to build anything of the kind. Easter Island, a civilization that raised 7 5-ton stone figures onto prepared platforms across a volcanic island and kept doing it as the world around them fell apart. The standard explanation for each of these, taken separately, is human ingenuity is greater than we give it credit for, and absence of evidence is not evidence of absence. Both of those things are true. They are genuinely true. But here is the inversion that changes how you read all 7 together. We think the complexity of ancient construction is something we understand, broadly, even if we lack a few technical details. The data says we don't. Not for these 7. For these 7, the honest answer from the engineering side, not the fringe side, the engineering side, is that the known toolkit does not fully account for what was built. That is a different kind of admission than, we're still figuring it out. That is the acknowledgement that something in our model of the ancient past is incomplete. These structures were not built by people who were primitive. They were built by people who knew something, possibly several somethings, that we have not recovered. Whether that knowledge was developed independently at each site, whether it represents contact between distant cultures, whether it reflects a much older technical tradition that most of our records simply predate, none of those possibilities can be ruled out by the evidence currently in hand. The textbooks will tell you these are solved problems, or nearly solved, or solvable in principle with enough rope and enough workers. But the engineers who stand in front of these walls, who run the calculations, who ask what tool cut this face to this tolerance, a surprisingly large number of them come back with the same quiet answer. Not aliens, not magic, something we haven't named yet. And what stands above the ground at these sites is only part of what there is to find. Several of them, Giza, Göbekli Tepe, Sacsayhuaman, have significant subsurface features that remain only partially explored. What's below the surface? What was sealed away? What was built and then deliberately buried? That is where the next chapter of this story lives. And that is exactly where this channel goes next.